everyone and turn control over to Miss Elizabeth in just a second. In fact, maybe let's turn control over now. I'm going to turn control over to you, Elizabeth, and just to make sure. So we're gonna stop the slideshow and just make sure everyone can see Elizabeth's screen because she is on a different computer. So I'm making her a presenter, and here we go. So for just a moment, it kind of should go to the holding position, and then you should see Elizabeth's screen. So we're just going to wait. Ooh, we got some fun things going on there.
Okay, so are you seeing my Sketchpad screen?
We are, and things are moving. It's a little slow.
It's a little slow, huh?
It's a little slow, but it's pretty cool. All right, so if you are not seeing Elizabeth's screen, please let us know by typing something in the chat panel. It is I will say it is a little small, Elizabeth, so I don't know if you can work with your resolution.
Small?
So I'm going to go ahead and get started and give everyone some webinar basics. My name is Karen Greenhouse. I'm the PD manager here at Key, and our speaker today is Elizabeth DeCarly. She is a managing editor here at Key Curriculum Press. Also on to help answer questions are Daniel Scher and Scott Steckety from KCP Tech. So they'll be answering some of our questions that come up. And so during the webinar, you all will stay on mute, and that is to just cut back on background noise. And so if you have questions that come up as you're viewing what Elizabeth's doing, you need to type them in the chat forum, and one of us will answer them, or possibly someone who is in the audience will answer them. So that's the best way to get your questions answered during the webinar. And we do our best to get to them as quickly as we can, and sometimes Elizabeth will just answer those out loud if it's something she can show or demonstrate. You can make your chat window larger if that is something of use to you by clicking where you see the chat panel. There should be next to the X a little enlarged screen, and that will make it larger. We do have some GoToWebinar does have issues with those of you who are on a Mac, and I do believe that feature of enlarging the chat window is not available for a Mac user. So just so you know that. Also, you can make your viewing screen larger. If Elizabeth's screen's not filling up your computer, you can also enlarge that by, again, clicking the little enlarge button next to the X at the top, and that will enlarge that screen for you. Or you can go to the view at the top of your chat. So I'm going to let Elizabeth go ahead and get started, and thank you for joining us. And Elizabeth, I'm turning it on to you.
All righty. Thank you, Karen. And Karen said my screen looks a little small. I'm hoping it's big enough because it's absolutely filling my monitor right now, and if I change my resolution, I'm worried it's going to kind of mess with the stuff that I've prepared. So let me know if it's too small, and I'll change things up. But I'm going to try this for now, and just let us know through the chat panel how it looks for you.
But again, they can also change their own view by making it bigger, going to full screen. So hopefully that'll help.
Great. Okay, so Karen already introduced the helpers. I really appreciate Scott, Daniel, and Karen helping me out today. It is nice to have people in the background answering questions so I can listen to their answers or look at their answers and kind of focus on the Sketchpad driving. I was a classroom teacher for 9 years at a big public high school in the San Francisco Bay Area, and I was a technology coach for 2 of those years, and I worked with teachers on integrating technology, including Sketchpad, into their math teaching. So that's my background, and I've been at Key as an editor for almost 7 years now. So I want to start out by finding a bit out about you, the attendees, so that I can understand, something about you. So I'm going to send out a poll right now, and let's see how this works. I'm going to go ahead and launch it. And if you could answer the poll, there should have a poll on your screen. And I'm seeing, okay, good, about 88, 93% voted. I think that's good enough. And you should be seeing the poll results. It looks like we have about almost 60% using version 5, 25% using version 4. Some people aren't sure, which I understand. Sometimes you don't know what your school has, and some of you are completely new to Sketchpad. So good variety there, and helpful for me to know that. Okay, and I'm going to do one more poll, and I know the answer for some of you because I've seen that some folks are here from outside of the country. So for those of you who teach in the United States, has your state adopted the Common Core state standards? And let's see, this is interesting. I'll wait for, okay, some people are opting out of this one, which is okay, 88%, 90. Okay, so I'm going to close that and share the results. So about 70% have adopted the Common Core state standards. For those of you international users, these are mathematics standards from our kindergarten all the way up through high school for mathematics and English. And some states have opted to sign on to them, some haven't. So we've got a mix here. I'm not going to dwell on the standards too much, but I'm going to point out a couple standards that we're hitting today. So I won't take much time with that, though. Okay, so in the first two activities, we're going to be focusing on a few different standards. One of them, this standard from the 8th grade, function standards, actually gave me the idea for our first activity where it says give examples of functions that are not linear. For example, the function a equals s squared, giving the area of a square as a function of its side length. So that gave me the idea for the first activity we'll be doing. This standard, understand that the graph of an equation in two variables is a set of all of its solutions plotted in the coordinate plane, often forming a curve. I feel that this standard is actually deceptively deep and difficult, and it's something that we sort of try to help our students grapple with. And I think that Sketchpad brought me to sort of a different kind of understanding of this concept. So I'm hoping to share that with you today. And the last one has to do with the domain of a function. And there's an emphasis in the Common Core standards on modeling, using mathematics to model real-world context, or perhaps geometric context. And so that modeling makes it important to discuss domain and how a mathematical model you might need to restrict a domain to capture a context. Okay. So I have one other poll question before we start. Just for I'm figuring out what you guys have seen before, and this is specifically about Sketchpad. Have you used custom tools in Sketchpad? Okay, and about 88% have voted, so let me share those results. Okay, so about 62% of you have used custom tools, 28% no, and 10% aren't sure. Okay, I will be using a couple of custom tools today in the webinar, and I can show you how to access those at some point. I can show you how to access those if anyone has that question. So I'm going to go ahead and hide the results and get started. Okay, so I'm going to start with that most daunting and yet exciting of things, a blank screen in Sketchpad. So we're going to start this one from scratch, and I am going to use a custom tool for this one to speed things up, but you certainly don't need to. Okay, so the first thing I'm going to do here is I'm going to bring up a grid, and I am going to snap points for this portion of it. Okay, the custom tool that I'm going to be using, there's a regular Polygon tool that comes with Sketchpad, and again, just to save a little bit of time, I'm going to use these custom tools for this activity, and I am going to construct a square by edge. And because I've done snap points, when I drag this square, notice that it's jumping along the grid, okay? And I'm going to go ahead and move my grid down a little bit. And just because I want to, I'm going to change some colors. Oh, come on, don't stick there. Okay. All right, now remember the standard from this last page, the function a equals s squared, giving the area of a square as the function of its side length. So we're going to be looking at that first. And to do that, I need to measure the side length, and I'm going to also measure the area. And I can see that, indeed, as I change the size of my square, those measurements are dynamically changing. And again, I set this up to snap to grid to start. I won't leave it that way. Okay, that was an 8th grade standard, and I think it's handy to see measurements in a table. So I'm going to go ahead and tabulate these measurements. And as I'm going to record by double-clicking. As I change the size of my square, the measurements come up in the table. And I'm going to, now I hope that my square is looking square to all of you, because on my screen it looks not very square. So I hope it's looking square to you.
It's looking pretty square, Elizabeth.
It is?
Yeah.
Okay, good. All right, I'm going to move this guy down. Okay, so I now want to graph the values in my table. So I've selected the table. And up in the graph menu, I'm going to choose plot table data. And I can check here. I'm choosing my side length as my independent variable, and I'm choosing the area as my dependent variable. So I think I can agree to that. And I see that the 5 points from my table have been graphed here. Okay. So I am, and as a teacher, I want to relate, make sure that students understand, what does this point represent? Well, this is my square with side length 1 and area of 1 square centimeter. And this one represents a side length of 2 and an area of 4, and so forth, and so on. Okay, now, that's great. I'm seeing that this is a nonlinear graph, which was, again, relating to my standard. But I want to see what happens when I don't have integer lengths here. So I'm going to go ahead and turn off snap points. And now I can see that as I vary the size of my square, I'm getting all kinds of crazy numbers in there. And now I'm going to look at what that looks like on the graph. So the two commands I'm going to do next are the commands that really gave me some extra insight into a graph of a functional relationship. So I'm going to select those again. So I'm selecting the side first and then the area, and I'm choosing plot as xy, and I see the point highlighted up there. That represents an x value or side length of about 4.12 and an area of about 16.96. And as I vary my side length, I can see that point moving. Okay, and so that's pretty powerful. But to really bring it home, what I'm going to do is I'm going to trace that point. And now, oops, I think I just traced this one, didn't I? Let's try that again. So now, as I vary the size of my square, I can see a representation of all of those different side lengths and the corresponding area, and I'm really getting a sense of what this functional relationship is. Okay, so then my next question would be, what equation can I graph that will model these data? I'm not sure why I wobbled there. I'm going to erase Okay, so what function can I graph that will model these data? And I kind of gave it away by showing you the standard first. So I'm going to go ahead and just plot my function. And y equals x squared. Okay, and now I can see that this function is a pretty great model for the relationship of the side of a square to the area, or the area to the side of a square. Now, the third standard that I showed you had to do with domain, and I would ask the question to my students, how is this model different from the data that we collected from the square? And hopefully they would notice that all of these points on the left side of the parabola represent negative x values, which don't really make sense in the context of this problem. So what I can do in Sketchpad is actually select the graph. I can edit the properties. And if I want to, I can set my domain. And I'm going to say that the lowest that the side length can be is 0. And now I can see I actually have a pretty great model here for this relationship. Okay. So that was the activity that came to me after looking at that first standard that I showed you. And then I started thinking some more about other kinds of quadratic relationships. And I'm going to move to a page where I have the same thing built, but it's a little bit cleaned up. Okay, so just to show you, you've got the same thing going on, but I've taken off the table and the graphed points because I want to explore a little bit more. Okay, I've looked at the area, the relationship between the area of a square and its side length, and now I'm going to take a look at an equilateral triangle with the same side length. So I'm going to go ahead and select the same 2 points that I used for the side of the square. And I'm going to, now what I'm doing right now, you can't see because I'm not using the menu, but I'm right-clicking it. I'm going to send the square to the back so that I can now make my triangle a pretty color. Okay, and I'm going to go ahead and measure the area of the triangle. Okay, so the area of the square with a side length of about 5 is about 25. The area of the triangle is less than that. It's about 11 square centimeters. And as I vary the side length, you can see very well that the area of the triangle is always going to be smaller than the area of the square. So the question that I'd like you to answer in the chat, if you don't feel shy, is if I graph the side length and the area of the triangle, what is that graph going to look like? Is it going to be another parabola? And how is it going to be different from this graph other than that? So if you can tell me, if it is a parabola, how is it going to be different? Is it going to be the same? Is it going to be moved up the y-axis? Is it going to be skinnier? I'm kind of asking you leading questions. I should just let you answer. Okay, I'm seeing one answer. Okay, I'm seeing a couple answers. Okay, so I've seen a couple people make the prediction that if we graph the side length and the area of the triangle, that we will get a wider parabola. So I'm going to test that out. And I want to make that one purple. Why does it keep sticking there? Make that purple because I like color coding. And let's check it out. Okay, so I can see, because I have attached the triangle to the side of the square, it's nice because I can drag point A and C both. Now I'm going to go ahead and trace that point. and get a picture of my graph. Okay. And the people that predicted that it would be wider, I am thinking that your prediction is correct. Now, there's one aspect of this that I think is a little bit hard to see, and so I'm going to go ahead and do a construction here to highlight something. I'm going to construct a perpendicular line through that point on the square graph. I'm going to make it thin, and I'm going to make it dashed. And the reason I've done this is that for my eyes anyhow, it was a little bit hard for me to tell that these points are directly stacked up on top of each other. They have the same x value. Okay, so when I add the vertical line there, it sort of helps me see that for the same x value, which is the side length, we can see the two different area values for the square and the triangle. Okay, so now, next question I'm going to put out to you is what equation can I graph to model this purple curve, the area of the triangle curve? What equation can I use? And this isn't an easy question. So you might want to think about, this is an equilateral triangle here. So you might want to think about what you know about the area of an equilateral triangle, how you can get that area using this side length here, AB, and in fact, to give you a hint, I'm going to label that one X. Okay, so I'm seeing some. I am seeing some good hypotheses there. So I'm going to try one of them. One of the hypotheses was that it would be 1/4 times x squared. Okay, so that model looks like it is going to be too wide. So any other ideas there? Okay. Okay, I'm seeing a couple of answers agreeing there, and I would normally like to do a little bit more testing, but I'm going to go ahead and short circuit a bit of exploration. Sorry about that. So what I have here is square root of 3 divided by 4 times x squared, and okay, can you see that highlighted? So I'm going to hide this guy for a second. So yeah, so this equation here is a function that will model the area of an equilateral triangle, okay, where x is the side of the triangle, and this expression, square root of 3 over 4 times the side length squared, gives the area. Okay, so this activity brings in actually quite a lot of geometric knowledge, and so although the first part of the activity might be appropriate for maybe 8th grade, I think the second part might be a nice tie-in for an Algebra 2 class to review some geometry and then really think about modeling geometric relationships with a function. I see an oops there on the chat panel. No problem. This is a different way of thinking. And as I said to you, Sketchpad really kind of turned my understanding of graphs of functions on its head. So that's kind of the point here. All right, I think I need to pause and see if there are questions.
There's not a lot of questions. I think everyone's really paying attention here. There were a couple questions about your custom tools, but I think Scott answered that, but I didn't know if you want to talk about that real quick. I did want to point out to everyone, on Elizabeth's screen, it looks like Elizabeth's mouse is about a couple inches away from the thing she's actually selecting, and that's actually... So it's a little disconcerting. It's not Sketchpad. It's actually because Elizabeth's on a Mac, and a Mac computer for some reason has slight compatibility issues with the GoToWebinar service. So it's because of the fact she's using a Mac. So she is doing the right menu, and your mouse just looks off to the side for some reason of everything you're selecting.
That's weird.
So that's why. It's because she's using a Mac. So.
Okay, and I'm going to tell you that what's really weird from my end is that I cannot hear any of you, and this is a very strange sensation for me. I've not actually done this kind of presentation out into silence before. So I appreciate that you are interacting in the chat panel, and I glance over there every once in a while to assure myself that people actually are out there in webinar land. Okay, so I will pause to talk about custom tools for a second.
But can you answer a question real quick that just popped up? It's a great question from Lori, and it says, why is the equation of the parabola of a square the same equation as the area formula, but not so for the equilateral triangle equation?
So that is a really good question. I am perhaps using a bit of arcane geometric knowledge here, which is that for the area of an equilateral triangle, you can use the 1/2 base times height formula, certainly, but if we only know the value of one side for an equilateral triangle, that side length will be, the same for all three. We do have some other information. Let me actually, can I go ahead and draw another triangle? I think it'll be easier to talk about this. So in an equilateral triangle, we know that the three sides are equal. We also know that the three angles are equal. So these three angles will each be 60 degrees. And if I construct a height, I've just constructed a midpoint. Sorry, I did that with a keyboard command. And so I'm constructing a height of this triangle. If this entire side here is, I'm going to use my marker tool. If this entire side here is x, then this little part here would be 1/2 of x. It's really messy. And this angle here is 60. We can use our special right triangle to find the height of this side, which turns out, or you can use the Pythagorean theorem. And it turns out that this side is going to be square root of 3 over x. Oh, okay, maybe I shouldn't have used the marker tool. It would be much easier on a whiteboard than it is with my little mouse. Square root of 3 over 2. So the area of this triangle using x would be, 1/2 the base, which is x, times the height, which is square root of 3 over 2x. So the long answer to your short question is we are using 1/2 base times height. The base is x, and the height is the square root of 3 over 2 times x, which gives us this expression for our coefficient. Does that answer the question? Oh, I feel better about my handwriting now. Thanks, James. Yeah, next time I'm not using the marker tool. So did that answer the question?
Yes, it did.
That says square root of 3.
Yes, it did. Lori said yes, it helped a lot. So awesome.
Okay, thanks. My writing is not really this bad with a pen. Okay, any other questions?
No, I think you're doing. You were going to do the custom tools. So real quick.
Yes. So Sketchpad 5 works a little differently than 4. So if you want to find the custom tools, on the Help menu, you will go down to Sample Sketches and Tools. And here's a whole bunch of sketches that are available. And in the Custom Tools document folder, I used the regular Polygon tool. And I may also be using the sliders tool. I haven't decided yet. So these, again, the way that you get to these is through the Help menu, Sample Sketches and Tools. And then once you're here, you just, I can select more than one by pressing the Apple button on a Mac or something else on
Shift.
a PC.
It's Shift.
Shift on a PC. And then just click Open, and I'll get those sketches. Okay, and we'll provide these these custom tools with the documents that we send you after the webinar. Okay. Alrighty. So I am going to investigate this concept a little bit more abstractly now, and I am going to attempt to build a slider from scratch, and if I mess up, then I'm going to grab a slider custom tool. So I'm going to construct a line using the line tool, and I guess it doesn't really matter if it's solid or dashed, and I'm going to label my points A and B. Oops. And I'm going to construct a third point, and I will measure the value of that point. And Scott will probably correct me if I'm wrong, but my basic understanding of this is that A and B have been designated kind of automatically by Sketchpad as 0 and 1, so the value of C is relative to those numbers on the line. And now I can hide the line and hide point B. Actually, I think I want to make this a little, I want to reduce my, is that going to work? Yeah. Okay, so I'm going to hide the line, and I'm going to hide point B, and I'm going to construct a segment joining A and C, and this will be a functional slider. Yay. Okay, and I'm going to rename this A. Okay, so I've created a slider from scratch. If I had messed that up or didn't want to take the time to do it, I could use a slider custom tool, and I have all kinds of fancy choices, including trigonometric angle sliders. So, but for now, I'm just going to use my basic slider, and I am going to graph the function A times x squared. So we're going to investigate the dilation of the quadratic function using this slider. And so if I vary my A value, then my parabola varies. And I'm going to make this thick. For some reason, I have kind of a sticky mouse today. Okay. So I did this kind of exploration with my students in Algebra 2, and I think it was helpful, but I think that an activity like this kind of brings home the idea that when the parabola is wider, kind of what's going on is the y value for any given x value is smaller. That's where this model helps my understanding out. I think for students, you know, this is very visual and very memorable, but sometimes I felt some of my students were just sort of memorizing that a big value of A makes it skinny, and a small value of A or a value of A close to 0 makes it fat, and I wasn't totally satisfied with that understanding. So my intuition tells me that some sort of combination of these kinds of activities would result in better understanding, and I would love it if any of you could verify that since I am no longer in the classroom. I want to show you two other features before we move on. One is that in Sketchpad 4 you had to do all kinds of fancy things to merge text, and it's a lot easier now with hot text. If I want to make an equation actually embedding this value, I can just click on it, and then I can enter the text like this. I can format it. And this will vary dynamically as I vary the value. So you could do that in Sketchpad 4. It's just a lot easier now in Sketchpad 5. And the other thing I wanted to show was that if I select my graph and select my slider control point here, I can look at a whole family of functions that shows kind of, I guess, a locus of all the parabolas that result from different values of A. So that is a pretty cool feature and just aesthetically pleasing, I think. Very nice. Okay. Any questions before I move on?
Not that I am seeing. So, Elizabeth, are you still there? Oh.
I am still here. Oh,
you sounded like you hung up.
No. No.
She said, that's it, I've had enough. Okay. No, I don't see any questions, so I keep going. Keep going.
All right. So I will keep going. All right. So the next one we're going to do, still in the realm of geometry, this is kind of a classic problem that we're going to model. Suppose you have some fence, a certain amount of fence, a restricted amount of fence, and you want to enclose the largest possible garden. We're assuming that this garden is going to be rectangular. And what rectangular shape would you choose? It would have been more interesting maybe if I had not placed that rectangular restriction on it, but that's what we're going to do for now. Okay, so I'm going to go ahead and construct a rectangle with a fixed perimeter, and I am going to do that from scratch. So I'm going to construct a segment, and I'm going to construct a smaller segment right on it. And notice it automatically kind of makes that dashed because it recognizes that it's not, I don't know how to say that it's somewhat extraneous to my important segment here. Okay, and I am going to construct two perpendicular lines. Construct menu. Okay, and I am constructing a circle with a center of C and a radius of CB. And to construct an intersection of the circle and the line, I just have to move. If you look at the lower right corner of my sketch right now, you can see click to construct the intersection. So I've constructed an intersection there, point D. And now I'm going to construct a line parallel to my base here through point D. And I'm going to construct this intersection by clicking. Okay, and so now I have a rectangle ACDE. And I'm going to use the Polygon Tool, which is a new tool in Sketchpad 5, to just outline my rectangle and create an interior for that rectangle. Okay, and once I've done that, you can see that all the construction lines become dashed. Okay, all right, so now I have constructed a rectangle, and let's see how it works. Okay, I can drag point C, but it's kind of restricted by B, so I can only drag it to the end of that segment, and I can only drag it to the other end. So, okay, so that's how the construction operates, and now I'm going to measure the area in the perimeter. And notice I've just selected the interior of the rectangle there, and I can measure the perimeter and measure the area. And free up a little space here. Okay, and notice as I drag point C, the area is changing. In fact, I get it all the way really, really close to 0. It disappears when the rectangle disappears. But the perimeter is staying constant. So what I've done is I've constructed a rectangle with a constant perimeter, but the area can vary, and that will let me answer this question. Okay, and I'm going to go ahead and measure two of the side lengths. I'm going to measure them. AC and AE. And now to free up a little bit of territory on my screen, I am going to hide my construction lines and circles. Okay, so let's see how this goes. Okay, so first question is, what seems to be the largest area that I can get here, and what shape is the rectangle when I have that maximum area? So go ahead and answer this question. I'm going to go slowly now. What seems to be the maximum area for this perimeter of fencing, and what shape is that when I have the maximum area? Oh gosh, you guys all know the answer. You must be a bunch of math teachers or something. Oh, it's pretty good. All right, so it looks like it's around 25, maybe a little more than 25, and I got a pretty good match there on the side lengths being equal. Okay, so I'm going to once again use my favorite command, which is plot as XY, and just so that I remember what I'm doing here, I'm going to move the area down, and I'm going to plot the side length, one of the sides, and the area, plot as XY. And I'm going to move this down so we can see. I think I might want to hide the grid. No. Okay, there we go. Hide the grid. So again, H represents the side length as the independent variable and the area as the dependent variable. And that is looking like a familiar graph. And this time, instead of tracing, what I'm going to do is I think I'm going to construct the locus. And what we can do is, I hope this works, select point H and point C and do construct locus. Okay, so instead of I could have traced first, and I probably would trace first with students, but I've now constructed the locus of point H as sort of bounded by the movement of point C. Okay. All right, so questions I would ask students are, what does it mean when H is at its peak? And hopefully they're going to recognize that that corresponds to the point when the rectangle has its greatest area, and that looks like it's at the point 5.04, 25.45. With students, you might, even further emphasize this by actually measuring the coordinates so that they can relate that back to the measurements on the screen. So you're always making those connections. Okay, and so once again, I have to ask you guys the hard questions. I would like to graph a function that will model this relationship. So do any brave folks want to give me an equation to graph? In the chat panel.
Elizabeth, while we're waiting for hopefully some people to respond, when you get a chance, maybe at the end of this particular activity, there was a question whether you could demonstrate hot text a little bit more. So,
okay.
Just something to keep in mind.
All right.
Throwing it out there.
That I would be happy to, especially because I think we're going to run out of time before we get to my last activity, unfortunately. Good note to self. Okay, so any suggestions for a...
Got one from Oscar there.
You know, I think I feel like I need to give you guys a little bit of a hint here, which is let us assume that AC here is X. Okay, so that's a hint, and another hint is that you might want to use this value, and I'm going to relabel this P for perimeter. I'm going to relabel this A for area. Okay. Okay, so this is interesting because I'm seeing answers that I wasn't expecting, and I have no idea whether they'll work. So I think I'll try one. So one of the ones I'm seeing is negative x minus 5 squared. Oh, you know, kind of looks like it's close to the right size of parabola.
Mm-hmm.
You might need to transpose it up. What I'm hoping you'll do is think in terms of an equation that will work even if well, I don't know how to give a hint without giving this one away. I have another test, which I'm going to try, and then I'm going to, maybe I won't tell you the answer. I may leave this one as a puzzle. What do you think? X times X minus P perimeter over 2. Ooh.
Wow.
Gosh, what do you think would happen if we flip this one around by perhaps, ooh.
Wow. Very impressive.
Okay, so the equation that I had in mind was something like this, similar to this. We know that if we call this side x, we know that to get the area of a rectangle, we'll do base times height, and we have one of the sides. The question is, how can we express the other side in terms of the perimeter and x? And if you think of AC plus DC as being half of the perimeter, oh, should I try the marker tool again? No. I can't write. I have a left mouse. I didn't use that excuse before, but I'm mousing with my left hand and I'm right-handed, so it's adding to my difficulty. So AC plus DC is half the perimeter. So if I subtract x from half the perimeter, I will get the length of the height. If I subtract the base from half the perimeter, I will get the height. So I'm going to write this in a slightly different way, but an equivalent function. So if I multiply the base x times 1/2 the perimeter minus the base, I'm saying that this expression here, 1/2 the perimeter minus the base, should give me the height. And hopefully, these two expressions are equivalent. Okay, so those are two ways that I can model that graph. Just to let you all know, what I'm doing here is I'm asking you to explore more questions from the activities. So these are the questions you give out when you have those students that are quick to finish and quick to ask you for more to do. These explore more questions are great ways to digging a lot deeper into the mathematics. And I'm kind of throwing these at you without a lot of warning. So thank you so much for stepping up and answering in the chat panel. Karen, you said that someone wanted to see some more on hot text.
Yeah,
And I also was wondering if there are any other questions. So
haven't seen any questions for a while. So,
okay.
So if anyone has a question, now would be a great time to send it in.
Okay, so I can, with hot text, if I click on an object in my sketch, it records it in the hot text, and anything that is dynamic measurement or value is dynamic in hot text. So I can now, if I vary the size of my square, those values will vary in my text. This is great for student presentations. If you want to have students come up and explain a concept, this is a great way to do it. Sketchpad 5 is very compatible with whiteboards, and this is a nice tool for presentations, whether by a student or a teacher on a whiteboard. The other thing I mentioned before, I'm really big on color coding. So if I were doing this demonstration, I might, you know, let's see, am I going to be able to do this? I might do some color coding, and I can do that with my hot text too. I don't know exactly why, but it really helps me to sort of bring together the elements. I might also color code that side. So I like to sort of use color as an element for drawing my attention to what am I measuring here? Yes, it's this segment, and that's what this measurement is here. Notice that when I highlight the measurement, it also highlights up here on the screen. Okay. Any other?
Well, yeah, there's actually a request. They wanted to know if you could unhide everything so that you, before you leave this sketch.
Oh, to show the construction?
Just to show, yeah.
Okay, sure, absolutely. It's going to be a mess. Not too bad.
That's not that bad.
Yeah, and I'm going to give you the, you know, the activity worksheet, which has all the steps for doing this construction, as well as the answers, and so you'll get that as a zip file with your webinar material. So you'll have all the instructions for constructing this.
Okay, that's it.
Other questions?
No, there's no more. So you have about, technically about 8 minutes left.
Okay. All right. I'm just going to show the beginning of my last one, and I'll send you the whole activity. So don't fret. You will have all the instructions you need to carry out the full thing. I'm going to skip the standards, though. Okay. So this is from an activity called Quadratic Quandary, and this is what I'm showing you now is a presentation sketch. That's pretty neat. If you want to start directing students' attention to the symmetry of a parabola, the question here is find the vertex of the parabola, and students can kind of fiddle around with these to realize that the vertex is going to fall right on the line of symmetry, so they can kind of eyeball this and maybe move the horizontal line to get a sense of where the y-coordinate is going to be. And this is a small detail, but one thing I really like is even my Algebra 2 students really kind of struggled with the equation of a vertical line being x equals, a value, and the equation of the horizontal line. So I like that this reinforces that. So I'm going to estimate that this vertex is around 3.3 and -2 for y. And now I am going to reflect that parabola across this line of symmetry, and I'm going to confirm the location of the vertex by seeing when these guys line up. Okay, and that is looking pretty good. So it does look like the line of symmetry is at about x equals 3.32. I think I should have written down what I guessed, so it's a little bit off from where I was. Okay, so that's just kind of an opener for this activity. I don't think I have time to go through this, so I think I'm just going to give you kind of an overview of what you do, and then I will send you the activity notes so you can see. The basic idea of this activity is that using the symmetry of a parabola, students learn how to construct a tool that will give them the vertex. And there's a couple of features of Sketchpad 5 that are used here. One is that you can now find the intersection of a function with another function. So I can construct the intersection points here. That allows me to construct a segment connecting those symmetric points on the parabola. If I construct the midpoint of that segment and then construct a perpendicular. I'm giving you a quick overview here, but you'll have all the instructions for this. I can now construct a perpendicular line that will go exactly through my vertex point there, and I've just constructed an intersection. Okay, I can measure the abscissa and measure the ordinate of that point. Okay, and again, we're really drawing students' attention to the symmetry of the parabola, using that symmetry to do this construction. Now what's cool is if I now press the new parabola button, my tool that I've just constructed still holds together, and I have the vertex of the new parabola. Okay, now my tool failed me because this line, which was essential to my construction, is now no longer intersecting the parabola. So I just need to drag the line down, and then my construction comes back into existence. And again, I've constructed the vertex there. This activity goes on to actually have students create a calculation to calculate the A value, the A value for this parabola in ax squared plus bx plus c form, I guess, or in vertex form, probably more likely. And so again, I'll send you the activity notes so you can experiment with that yourselves. And I'm sorry we didn't get to that. I want to spend a couple minutes showing you something a little bit outside of the topic of this webinar, but first I wanted to see if there were questions. So questions first, and then I want to show you 3 cool things before you go.
No questions that I can see. So if someone has a question, just type it in now. If not, show us some 3 neat things.
Okay.
I'm excited.
Okay, so I'm going to show you 3 neat things. So we have a sharing site now called Sketch Exchange, and you can get on here without logging in if you want to just browse around. And
that's scary.
That's Nick. Nick submitted this. So on the home page, we feature some contributions. And so I wanted to show off 3 contributions that I think are really neat. One of them is this, and I'm going to show you the actual sketch for this. But I just wanted to let people know that you can browse on here and download sketches that people have submitted without being registered. If you want to rate a contribution or you want to contribute your own, then you'll need to log in, create an account through Key Online, and we just require basically your name and your email address. So it's not a big, don't worry, you don't have to, sign away your firstborn child to join. We just pretty much need your name and email for you to register. But you can download without being registered if you want to browse and see what's there. So the 3 cool things I'm going to show you are, first one I just sort of highlighted for you. Someone contributed this. It's called the walking.
It's kind of way over on the right, Elizabeth.
Yeah. Well, yeah. I'm going to make it
walk. Oh, that is so cool.
Okay. So that was my first.
That's really cool.
That's my first cool thing. I think it walks all the way off the screen. My second cool thing is this steam engine. And I know you're going to say it's way off the screen, aren't you? Let me shrink it down.
It's pretty off the screen.
Okay. How's that? Can you see if I start the engine? Can you see this?
Yeah, parts of it, like not the whole thing, but
okay.
Parts of it, yeah.
Yeah, this is a big sketch. So this is a Sketchpad model of a steam engine, including the path of the steam going in and out, and there's a couple other engine models, another contribution to Sketch Exchange that is, I think, super cool. And then the last one is to inspire all of you classroom teachers. This contribution is from an 8th grade, well, it's the teacher of an 8th grade student. An 8th grader constructed this diagram of trig tracers for different trigonometric functions. And I was really impressed that an 8th grader constructed this. He has the points around the unit circle and everything. So that's to inspire your teachers to think about getting your students working on Sketchpad and not just, it's great to use it as a demonstration tool, but I think it's even more powerful when students can work on it themselves and create their own constructions.
Elizabeth, somebody wants you to go back to the steam engine and show the fast speed.
Okay. What do they want to see?
Fast speed.
Oh, okay. All right. I haven't even tried it. Woo.
Woo!
Okay.
All right.
Pretty cool.
Pretty cool.
This sketch was done by a college student as a project for, I think, a mathematical modeling class. So he chose to use Sketchpad to model these steam engines. I think it's really, really neat. Okay, any questions?
The question was, got any calculus applications? So I'm sure there are in Sketch Exchange, right? There's got to be.
Oh, yeah. In fact, we even have some that are question answerer and all-around wonderful resource Scott posted. So in the secondary school, actually I think it's under advanced topics, we have calculus. And you can see the contributions at the calculus level. So, yeah, so we have 2 pages worth of calculus.
Oh, and Daniel did bring up that we do have a Sketchpad module book that's all devoted to calculus and tons of activities.
We have Exploring Calculus with the Geometer Sketchpad if you want a whole book of calculus activities. Excellent point. All right, any other questions or comments?
The question came up, is this for Sketchpad 5? You might want to talk about the activities and their compatibility with Sketchpad 4, because I know we have some
So
users.
In the Sketch Exchange, you can actually browse by version. So some people are posting Sketchpad 4 activities. And so if you have Sketchpad 4, you can, this is now sorting them, but if we go to the end, we will see all the Sketchpad 4 contributions. So we have plenty of people that are contributing for Sketchpad 4, and we do have that as a sort, you can sort by that. So in terms of Sketch Exchange, yes, there are Sketchpad 4 and Sketchpad 5 sketches. If you have Sketchpad 5, you can open all of the Sketchpad 4 contributions, like that steam engine I just showed. That was done in Sketchpad 4. This was done in Sketchpad 4, so you could open it in Sketchpad 4. In terms of the webinar today, we'll be sending all these out in Sketchpad 5 versions. The Quadratic Quandary in particular won't, we don't have a Sketchpad 4 version of that because it uses some features like the intersection of functions that didn't exist in Sketchpad 4. Did I say that correctly? It only exists in Sketchpad 5.
Right. Okay. Well, I don't see any other questions. Some interesting comments.
Okay.
So thank you, Elizabeth. This was great. And thanks, Scott and Daniel, for staying online and answering questions all the way through. And thank you, everyone, for joining us. And again, just a couple reminders. We will post the recording of this webinar. It's usually up by Friday. And it will also include a zip file that you can download of the sketches that Elizabeth used and the activities, worksheets and such. So that's going to all be up by Friday, just so you know. And you all will also receive an email from me containing a certificate of attendance. So if your school district accepts things like that, you can use it for PD credit or continuing ed units, whatever they call it in your district. So thank you very much for joining us. And if you haven't, one of the things we ask is when you leave the webinar, there's a really short survey, and we ask that you complete it and give us some feedback, questions, concerns about the webinar, things you'd like to see in the future, because it does help us as we plan for our future webinars and as we continue to try and improve these webinars as we go along. So thank you again, everyone, and we hope to see you next month. Thank you. Mhm.